Welcome back to the deep dive. Today we're digging into a huge topic, the whole quest for radical life extension. Got a great stack of sources here.
Yeah, it's fascinating stuff. I mean, for ages, the idea was just helping people live longer, maybe reach their natural limit.
Right, that limit being, what was it, Jean Calment?
Exactly.
Yeah.
Don Kellman, she lived to 122 years and 164 days. That's like the documented record.
But now the goalposts have shifted, haven't they? We're not just talking about reaching 100 or 110.
Not at all. The modern goal is way more ambitious. We're talking about pushing past that biological limit.
Seriously past it.
Yeah. Some people, the life extensionists or longevists, they're aiming for, well, theoretically indefinite lifespans.
Indefinite, wow.
Through something called agerasia. Basically, complete rejuvenation. Think rolling back the clock biologically to a healthy, youthful state.
And the tools for that would be?
Things like advanced regenerative medicine, targeted gene therapy, really cutting-edge stuff.
Okay, so that's our mission for this deep dive. We want to lay out where things stand right now with this whole quest. We'll look at the biology, the crazy tech, the stuff you can actually do now, and even the politics and ethics around it all. Okay, let's unpack this then. If we want to fight aging, we really need to understand what aging is, right? What's the mechanism? It's not just wear and tear, is it?
No, not really. Scientists have moved past that simple idea. They talk about the hallmarks of aging.
Hallmarks?
Yeah, basically a set of specific interconnected biological malfunctions or failures that happen over time. These are the things they think we could potentially, interrupt or fix.
So what are some of these hallmarks? Which ones are the toughest nuts to crack?
Well, there's genomic instability, our DNA getting damaged, and telomere attrition.
Ah, the ends of the chromosomes getting shorter.
Exactly, those protective caps wearing down. But maybe one of the trickiest is cellular senescence.
Senescence. Those are the zombie cells I've heard about.
That's the popular term, yeah. They're cells that should die off, but don't. They just hang around.
And cause trouble.
Big trouble. They spew out inflammatory stuff, damage nearby tissues. It's a real problem.
So you've got unstable DNA, these zombie cells cluttering things up. Is that the core of it, the reason we see aging?
It's a huge part of it. Add in mitochondrial dysfunction, the cell's power plants failing, and oxidative stress from free radicals. It's a complex breakdown.
And it seems like this breakdown happens at different speeds in different species.
Absolutely. Which is super interesting, actually.
Because we see some animals that just don't seem to age like we do.
Right. Well, we top out around 122. You've got creatures like hydra, certain flatworms, even some jellyfish. They show what scientists call potential biological immortality.
Meaning they don't die of old age.
Essentially, yeah. Their aging rate seems negligible. It suggests the whole process is deeply tied to a species' genetics.
Which hints that maybe it's changeable.
That's the hope. The big goal isn't just treating age-related diseases like heart disease or cancer. It's changing the fundamental rate of aging itself.
Okay, so if the clock is genetic, you try to hack the clock. Here's where it gets really interesting, right? Let's shift to the high-tech stuff. The strategies aiming for radical extension.
Yeah, this is where things get pretty futuristic. Gene editing is probably the biggest player right now. Technologies like CRISPR-Cas9.
CRISPR. We hear a lot about that. Has it actually extended life in anything?
Oh, yeah. In lab settings, the results are striking. They've tweaked single genes in nematode worms and extended their lifespan tenfold.
10 times.
Yep. And in mice, similar single gene changes have led to roughly a 50% increase in lifespan.
Wow. Okay, 50% in humans would be game-changing.
Yeah.
That's like adding decades. But some people are thinking even bigger, aren't they? Like nanotech?
Definitely. You have futurists like Raymond Kurzweil talking about advanced medical nanorobotics.
Tiny robots in our bloodstream.
Kind of, yeah. The idea, pushed by people like K. Eric Drexler decades ago, is nanomedicine microscopic machines that could repair cells from the inside out.
Kurzweil thinks this could fix aging by 2030. That sounds incredibly soon. Is that realistic or just, hype?
Well, the 2030 timeline is, let's say, very optimistic. But the underlying concept, molecular repair, is a serious theoretical goal. Could tiny machines fix damage faster than it occurs? Maybe. It's the swallow the doctor idea.
Okay, beyond tiny robots, the sources also mention bigger replacements, like growing organs.
Right. Therapeutic cloning and stem cell research. That's moving forward, actually.
Yeah, you could do that now.
On a smaller scale, yes. For instance, scientists have successfully grown bladders from a patient's own cells and implanted them. It works.
That's
The
incredible.
more extreme end of this is the transhumanist idea of growing whole replacement bodies without consciousness for brain transplants.
Whoa, okay, that sounds ethically complicated.
Deeply controversial, yes, and highly speculative at this point. Reproductive cloning itself is already a minefield.
And while we're on controversial tech, we have to mention cryonics, freezing people.
Yes, cryopreservation. People pay a lot of money for it, hoping science can eventually revive them.
But the science.
Okay, let's be really clear here, because the sources are quite strong on this. The mainstream scientific community is extremely skeptical. It's often characterized as quackery.
Quackery. That's blunt. Why such a harsh dismissal? It sounds like the ultimate backup plan.
Because there's currently zero evidence that it can work. The damage caused by freezing itself is immense, let alone reversing the disease that killed the person.
So there's no proof you can actually unfreeze someone successfully.
None. And no clear path with current or foreseeable technology. So from a scientific standpoint, it relied entirely on faith in future breakthroughs that might not be possible.
Got it. Okay, so that's the far out stuff. Let's maybe pivot back to what's happening now, or at least being seriously researched in labs and pharma companies.
Right. Moving from the highly speculative to the nearer-term possibilities.
And importantly, trying to sort out what's real science versus what's just being sold to people.
Exactly. A big focus in pharmaceutical research is on drugs that mimic the effects of caloric restriction.
Caloric restriction, just eating less.
Yeah. Studies in some animals show that significantly restricting calories extends lifespan. It's quite a robust finding, actually. So the idea is to find drugs that trick the body into thinking it's restricting calories without actually starving.
What kind of drugs are we talking about?
Things like rapamycin and metformin are being studied quite intensely. They're called caloric restriction mimetics.
So if these drugs show promise, why don't we have an FDA-approved anti-aging pill on the market?
That's the big hurdle. It's regulatory. Currently, aging itself isn't officially recognized as a disease or a preventable condition by governments, including the FDA in the U.S.
Wait, aging isn't a disease? That seems counterintuitive.
Well, the FDA's official stance is that no medication has been proven to slow or reverse the aging process in humans. Because it's not classified as a treatable condition, it makes it very difficult for drug companies to run large-scale trials, specifically targeting aging.
And that regulatory gap, does that open the door for, well, less regulated stuff?
Precisely. It creates a kind of loophole. The commercial anti-aging market, supplements, hormone therapies, is absolutely massive.
So massive.
We're talking huge numbers. Back in 2009, it was estimated at around $50 billion a year just in the U.S. And it's likely much bigger now.
But you're saying these products aren't necessarily proven.
Many aren't, especially things like hormone replacement therapies promoted for anti-aging. They generally haven't been proven effective or even safe for that purpose.
And sometimes regulators have to step in.
They do. The FDA has had to warn companies, for example, those promoting so-called young blood transfusions, as an anti-aging treatment. There's just no solid proof it works, and it carries risks.
Okay, so forget the expensive, unproven stuff for a minute. What does work? What are the reliable, validated strategies for extending health span, the healthy years of life?
This is where we get back to basics, but the evidence is really strong. Diet and activity are absolutely key.
Like the Mediterranean diet.
Exactly. Higher adherence to a Mediterranean-style eating pattern is consistently linked with reduced mortality and better health in later life.
What about the wine aspect of that diet?
Good question. While traditional Mediterranean diets often include moderate wine consumption, the optimal diet research suggests keeping alcohol to a minimum for longevity benefits.
Okay. And antioxidants. For years, we were told to load up on vitamin C, vitamin E, fight those free radicals.
Yeah, the whole free radical theory of aging. It turned out to be more complicated.
How so?
Well, those free radicals, or reactive oxygen species, ROS, aren't just bad. Our body actually uses them for important things, like cell signaling.
So taking huge doses of antioxidant supplements might actually interfere with necessary processes.
That's the concern. And it's more than just a concern. Some big reviews have actually found that supplementing with certain vitamins, specifically vitamin A, as beta-carotene and vitamin E, might increase mortality risk.
Increase, so the opposite of what we thought.
Potentially, yes. It's a really stark reminder that more isn't always better, especially when messing with complex biological systems.
Wow, that's huge. So Pills might be out, or at least need extreme caution. What's left?
Activity. Good old-fashioned physical activity. The research consistently supports it.
I'm not sure, Doc.
Current guidelines suggest aiming for about 2.5 to 5 hours per week of moderate or vigorous activity. That seems to be the sweet spot for maximizing health benefits.
And other lifestyle factors.
Absolutely. Things like maintaining strong social connections, getting good quality sleep, these are consistently linked to better health and longevity. These are the tools we know work right now.
Okay, so let's zoom out again. We've got the basic science, the far-out tech, the current best practices. What about the bigger picture? The money, the politics? This isn't just happening in labs, is it?
Not at all. There's serious money pouring into this field, especially from Silicon Valley.
Like who?
Big names. Jeff Bezos, Larry Ellison, Peter Thiel, Sam Altman. They've invested heavily in anti-aging research companies and foundations. Think Calico, Human Longevity, Inc.
So the tech billionaires are betting big on cracking the aging code. Does that influence politics?
It certainly translates into advocacy. You've actually seen longevity political parties pop up in places like Russia and the U.S. Their main goal is to push for more government support for this kind of research.
And it's being discussed at really high levels.
Apparently so. Our sources mention, partially of course, a 2025 discussion between Xi Jinping and Vladimir Putin that touched on organ transplants and, quote, immortality.
Immortality discussed between world leaders.
Yes. With Putin reportedly talking about biotechnology, potentially making people younger and younger, it shows this isn't just a fringe scientific idea anymore. It's on the geopolitical radar.
Let's circle back to that regulatory issue classifying aging as a disease. You said the FDA doesn't. Why not? What's the argument against calling aging a disease?
The main argument, often associated with scientists like Leonard Hayflick, is that aging isn't like, say, influenza. It's a natural, universal process, an unavoidable consequence of entropy, almost.
A force of nature, not a pathology.
Kind of. Most mainstream medical bodies don't classify it as a disease because everyone experiences it if they live long enough. It's inevitable.
But the people who want it classified as a disease have practical reasons for
Very practical. They argue it should be considered a special sort of disease. Why? Mainly strategy.
Strategy how?
If aging were classified as a condition the FDA could target, it would likely stimulate much more research and funding for treatments from mainstream pharma. And, crucially, it would allow the FDA to regulate that huge, currently under-regulated anti-aging market much more tightly.
So it's about legitimizing the research and cracking down on dubious products.
That's a big part of the push, yes. Bringing it under proper medical and regulatory oversight, rather than leaving it in the realm of cosmetics and supplements.
Okay, last big area, ethics. If we could radically extend life, what are the big worries? Overpopulation seems like the classic one.
It is. Critics like Leon Kass raise that concern forcefully. Would society collapse under the weight of billions of near immortals? Would we lose our connection to future generations?
But there are counter-arguments.
There are. Some proponents, like Aubrey de Grey, suggest that if life extension also delays or eliminates menopause, women could have children over a much longer period. This might actually decrease the annual population growth rate, as births could be spaced out more.
Interesting point. What about fairness? Equity? If this tech works, won't it just be for the rich?
That's probably the biggest ethical concern. Philosophers like Nick Bostrom argue very strongly that any breakthroughs must be shared equitably.
The idea of creating a massive gap between the long-lived wealthy and everyone else.
It's a dystopian scenario many people fear. The social and political pressure to ensure fair access, if such therapies become reality, would be absolutely immense.
We have definitely covered a lot of ground. From, the nitty-gritty of telomeres and senescent cells all the way up to nanobots, global politics, and these huge ethical questions.
It's a really dynamic field. You've got the careful, rigorous biology trying to understand the mechanisms, and then you've got these, sometimes wild-sounding technological ambitions pushing the boundaries.
So the takeaway for right now seems to be focus on the proven stuff.
For maximizing your healthy years today, absolutely. That means things like the Mediterranean diet pattern, consistent exercise, good sleep, social connections. Be very wary of expensive supplements or unproven treatments.
While the radical stuff, the genetic engineering, the nanomedicine, that's still more of a future promise.
It is. It depends on massive scientific and technological leaps that haven't happened yet. Very exciting potential, but still potential.
It leaves us with a really interesting final thought for you, the listener. We mentioned polling. Most Americans think life-extending medical advances are generally good. But a majority, 56% in one poll, said they personally would reject treatments to slow aging and live to 120 or more.
Yeah, that's fascinating, isn't it? Why the hesitation?
Is it maybe because we associate living longer with just more years of being frail and sick, that deep-seated fear of a prolonged, decrepit old age?
Could be.
So here's the question to chew on. If science could promise not just longer life, but radically extended health, decades, maybe centuries of youthful vigor, would that change your answer? What would your ideal lifespan be then? Something to think about until our next deep dive.